I haven't done this for a while, but this time we're gonna do something different. This time we're gonna do something more base coding. So we're just gonna do simple algorithm. Usually I was doing more React and Node real project kind of work, but yeah, this time we're gonna try something different. Some friends of mine asked me to do that, so I'll go through that. I will create some. This time we're gonna look into breadth first transition of a graph or traversal. So that's just one of the ways you can traverse a graph. It's a quite common, interview question, and it's a very simple algorithm we can write up. I'm gonna be doing it in JavaScript because it's a kind of fun language, and yeah, it's easy to start with. So let's start with that. First thing I have in my head, I'm using VS Code, but the first thing I had in my head is that I would like to have some sort of tests to validate what I'm doing. So I'm going to do a little bit of test-driven development, or TDD, just to kind of showcase it, I guess. And for that, we need some testing framework, probably. There's Jest, so let's use that. That's kind of standard JavaScript testing library. So I'm starting with the nothing. I just have a JavaScript folder here. Wanted to start from nothing, and let's get to it. First, I'm gonna initialize this project, just so we have npm here, and I can slowly, install the dependencies like jest in my case, and then write the code. Yeah, sure. I'm gonna probably get rid of everything. Just want to have a package.json here. Perfect. Let's create a graph folder here, and then to set up jest, I think they have a quite nice get starting section. Right, so we can do this. So this line adds jest to our dependencies. Now it's installing. Well, what jest does, it's like a test framework, right? So you can write the use cases that you want to cover in your code, and then it has a bunch of assertion tooling, so you will get nice messages if something breaks and stuff like that. So that's why I'm installing jest, just opposed to manually doing it all the time. Well, another advantage of using test frameworks or tests in general is that you don't need to repeat all the time the tests you've already done. So if you add a new feature and you still want to make sure you didn't broke anything before, that's perfect for this. So now when we install a dependency that it is here in non-modules, you don't really need to look at because it downloads half of the internet, but it's here. So now I think we can do npm run test, maybe. No. When you say something like this, npm run something, it goes to package.json. Let me zoom in a little bit, maybe. Goes to package.json right here and looks for scripts and then the string that you set. So we set, sorry, this terminal is really small, but we set npm run test here, so that it's going to look for test script here and that do anything here, and here it says error not test specified. So here we get this error because this is what happened. What we want to do, I think it's just jest. Let me double check the thing. Oh yeah, they don't say what you're supposed to run, but I think it's just jest. Let's try that. they expect it will work. Cool. So it failed because it didn't find any tests, which is fine. We don't have any tests, so that's fine. Let's try to add the test. So what I said at the beginning, we're gonna try to do breadth first traversal. And then what's the naming convention there? I think it's, oh yeah, you do something test.json here. So file, and then we do breadth first traversal test JSON. Let's just steal some code from here. Just say expect, sorry. So this is the format you use when you're writing jest tests. Right now we're just saying this is the name of the test, this can be whatever. So this is our test. And then this is a lambda expression, but basically this is a function that's gonna get called. Let me break it out a little bit more. I don't have formatting. Sorry, let me just do auto format. Boom. So this is the name of the test, and this is a function to be executed, and it just kind of expect one to be free, which is false. So when we run the test now, hopefully, so you can see it found the test here in graph, and the whole trick is because I named it correctly. I named it test.js, and then it knows, jest knows that that's how you name tests. So that's why it went here and executed this piece of code. And also this function, test function, expect, to be, that all comes from jest. So we didn't require it or anything. It's because jest runs it, and it already have all the dependencies, so it kind of works. And that's the beauty. Now let me show it in a maybe bigger terminal here. I think I put it here. GitHub, my folder, JavaScript, yes. So it's a little bit easier to read here, but it tells you that it failed, tells you the name of the test, we just put our test there, and it tells you, you know, I expected it to be free, but I received one here, and points you exactly to the line and everything. Here you have the line, so it's really easy to kind of figure out what's wrong. In VS Code it has integration, so you can just click this place and it will tell you directly this is where the problem is. So if we fix it to be free, to be free, no, we expect number 3 to be actually free, and run that again. Successful this time, so this is perfect. All right, so now what we wanted to do. So first, the ultimate goal is how to handle this. I was thinking about printing something out, but that's a little bit difficult to cover in tests, but let's do return then. So as you might be aware, let's imagine we have a graph like this. Sorry. Horrible at this. Wait a sec. These squiggly lines don't help really. Let's do one more here. Let's do like D and E. So this is a graph, right? Put it in a comment. Nice. So this is a graph. You know, A is the root one, and that first level is here B and C. Those are like children of A, as you can see. And then B has a D and E. Is it still too little? Maybe it's too small. Yeah, and I guess we don't need this part. And we don't need this really, no. So let's just focus on that part. So we have A, and then second level is this, and then third level is this. Then there are two ways you can traverse a graph like this, or maybe more, but the most common ones are depth first search or traversal, and breadth first search or traversal. Why I'm saying search, because usually you just don't want to traverse a graph. The more common scenario is that you actually want to search. But the first step is the traversal, and then you do something with every node. And in search, you kind of compare every node to what you're looking for. And if you found the thing, that's the end of the search. But the prerequisite for that to work is that you have to have the algorithm to traverse the thing. So that's why we're doing just the traversal, not the search, because the search is kind of trivial after you've mastered the traversal part. So if you would do depth first search or traversal, sorry, I'm gonna mess it up many times. You would start at one point. You usually start at the root, which is A here, and then you would look at the children of that, which would be B and C. But because you're going depth first, you would look only at B and leave C for later. And then you would still go deeper, so you would go D next. Let me write it down. So in depth first traversal, you would go A, then B, then D, then you would go E, right? Because you're still processing this guy right here. You've done this, so you don't have any deeper to go. So you go one step up and check if there is more to do on this one. And B still has A child, so you're gonna process E now. But then there is nothing left for B to do, so it goes one level up and check if A has some child that is not processed, which is C in this case. So this would be C. By the way, I have a chat here. I barely sometimes miss it, but if you have questions, if I would be too confusing, feel free to do that. Well, now we're gonna check how it would work on breadth first transfer something. So this time we're gonna go level by level. So basically we start at A, same as before, but then we look at all the children A has, and it has B, and it has also a C child. So this one and this one, and then we're gonna go one level down. So you're gonna do D and an E. So that's the difference between those two traversals. We either go first deep, and then if we don't have anything to do, we go one level up and try to figure out if we can do something there, and then we go again one level up, and so on. And breadth first search is level by level. So that's how it works. Let's test another thing. So in the ideal case, what we want to get here is let's just write the whole use case. So we're gonna do breadth first traversal, I guess. And another thing is that we somehow need to kind of, maintain this structure somewhere in the code. So one way we can kind of interpret this structure, let's put it here, is that, let's do that. That's kind of easy. So for each node, we're gonna write what the child of that node is, right? So for A node, right, child is B and C. And for B node, the child is D and E, right? And then for C node, there's no child, but we still want to have this record here, maybe, just to make it easier for us. And then D, again, has no child, and E has no child. Perfect. And oh, sorry. Let me kill this so it doesn't bother us anymore. Cool. So this is pretty neat. The way I've written this is actually kind of, what do we call it? It's like an object in JavaScript. So you can do that. We can just send it as an object, the whole graph. So let's do that. So I guess we can say our graph here is this. And then I will uncomment these lines. So I said this is a const, meaning that I'm gonna initialize it here and it's never gonna change. This is actually quite a good way of doing stuff. So if you can use constants as much as possible, because mutable state is where a lot of errors happens. So that's why you really want to do const as much as you can, and do mutations as little as possible. There's a whole paradigm about functional programming that is kind of based around this, where you don't actually have an option to change variables. So you don't have variables really. So what you would use if you want to change something is kind of process it to a new thing and name that something differently, and continue further. What that helps you in the future is that when you're reading the code afterwards, you kind of know, if I would do something and have a graph 2 here, that's really not good naming. But if I would name it graph after conversion, already tells me something just from the name of the variable. And that's a very useful thing, like naming things so that you kind of can deduct what happened to them before or will happen to them, or what's the point in them in this method is really hard, but it really pays off. So that's nice. Maybe you just have a graph here, and then let's say we want our graph, we will have a function, let's call it, breadth first traversal. We send the graph in, and we expect to get nodes here. So yeah. So then we can say that we expect nodes to be, and this is the expected, we can even do this. We can do const expected nodes so if something became too convoluted, it's better to move it out to a separate constant, to name it, to kind of make it easier for people to read afterwards, because in software, like 9 times out of 10, what you do is just reading somebody else's code, and then do 1/10 of the time is adding your code to it. So if you optimize your code to be easily read by other people, that's really good. So this whole naming thing, that ties into it. And what I could have done before, right, is that I could say to be and then put the letters here somewhere. The problem with this is that this becomes a little bit harder to read, especially if this gets longer. So that's why I opted in to do this way. Well, and then we just want to do this, right? We just want these letters to be written, as we thought before. So let's do that. So this looks good. Okay, so let's try to run the tests. They look bad because we don't have the, let's open this up so then you can see it. Put my face there. Maybe I should put it on the second. That's fine. Alright, yeah, so it fails here. Not where we expected it to fail, but it's failed here because B is not defined here, right? And that's because, no, I wanted to use like a string here, but I didn't put it in the quotes, so that JavaScript thinks this is a variable name, but it's not, because there's no variable B here. So what we want to do is just put it in quotes, like so. Same kind of goes to the keys here, but because JavaScript understands this is an object and this is a key, this is not interpreted as a variable. You could do that if you want to. You could do like this, and then it would be a variable. But by default, this means just a key. Alright, so if we run this now, I think it should complain because of the function, right? So now it complains that this function isn't a function. And that's because we haven't written it yet. So what we're gonna do is write it. So here, I switch to another file, the one that will actually hold the code. That's one way you do this as well. You would move your tests to one file and then move your production code or normal code in another file. Which enables you to, in the future, is when you deploy this code, you don't need the tests anymore. Those tests are meant to be used by developers and in the development process. But then in our use case, we would just cut half of the package size by not including the tests file. So then here we will just have like a function with a traversal, and it takes one option, one paragraph, which is graph, and this is the code. And for now, let's just return an empty array. So this is all good. We still need to export stuff here. How does this work in JavaScript? Is it module? No, isn't it this? No, I know. It's module exports, right? And then you do this. I think. So the ways you export changes. Like, I mean, this is for JavaScript. I think you do this. Some say something which you can convert to is ES6 module, but then we're gonna run this with Node, maybe, or just the tests, and I don't know if that's supported. But this is the default, or like the this is JavaScript native way of doing it, I think. Let's test it out. So then, here inside our test, we would do. Maybe it can actually figure it out for us. No. We would do this. Goes require. Maybe. It's a long time I've done this. Cool. I think. Let's try to figure out if he finds it. Yes, perfect. So what we've done here is require is a way in JavaScript you kind of fetch out the files and include them in this file. So this is our test file right now, right? We're in this traversal test. but we want the real code here so we can test it. And here we're saying, get me anything in this file, and then it will go to this file, look at the module exports, looks at this object, and takes this object. And then here we say, from this object that you got, I just wanna this thing. So what you could do as well is do like this, right? Then you had the object, and then you say bread for search like this. But to make it easier for us, we will use so-called destructor right here. What does that do is you will name this key, and just you can use it directly. You can rename it as well here. You could say my cool function, and then in our call we could just call my cool thing. But that would be more confusing than not. And yeah, one thing I wanted to mention as well, this is also a JavaScript thingy. So this is an object, right? But it has only one thing. So is this a key or value? So this is just a shortcut for this. So if the key and value is the same thing, although this would be a string and this is the actual object that you want to, when I keep saying object, is because it could be variable, it could be function, it could be class, it can be whatever. But if they are the same, you can omit the right side and it will just work. Cool. So if we run the test again, where we can see it. Right? It fails where we hoped it to fail. It fails on this assertion. So we expect our result to be these expected nodes. And in the expected nodes we have A, B, C, D, E. And the array, which is what we got from the response, is nothing. It's empty. So that's really good, because we're getting somewhere. And it's because we're returning empty array here in our function. So now let's start writing it, I guess. Well, there are two things you can do with this, two ways you can do this. There's a iterative approach, or you would use recursion. Those two ways, they both have benefits and drawbacks, but you can write one using the other. So you can always you can rewrite the recursion into iterative approach and iterative into recursion. What those two ways means is that recursion means that this function or some function would call itself in its body, while iteration means that you would have some loop in it. So like a for loop or while loop or something like that. Iteration is usually considered to be easier to think about, but recursion is when you get more into coding, recursion is actually easier to think about as well, but depends on your level a little bit. But let's start with iteration, and if we will have some time at the end, we can try to look into recursion, or I can leave it up for you later. So okay, so we have a graph, right? And we didn't, right, we need one more thing, which is like a starting point to know where to start from. So this is like a route for us. So we need to go back here. And this is A in our case, right? So this is, we need to know where to start from in this graph. Because one thing about graphs is, if you would start from here, it's still a graph, it just looks different, right? So we need to tell it where is the starting point. So we're saying A is the starting point. Okay, and now the way you do these traversals is that you choose a proper way, a proper structure to hold these nodes in. So what you do in breadth first traversal is that you would use a queue, which is first in, first out kind of structure, as opposed to a stack, which you would use for depth first search, which is a first in, last out kind of thing. Right? So let's see. So imagine there's a queue, right? And then A comes in, right? So the next step, A is in the queue here, and B wants to come in. And next step, B is in the queue as well, and then C wants to, and we want to take something out. So we would take out from this side. Sorry, these graphics are horrible. So we would take out A and leave B here. So that's Q, because the A was first in, it goes first out. As opposed to stack, let's write Q as opposed to a stack structure, where you put A in, you put B in, same thing, but then when you take stuff out, you take from this direction. So you would actually, A would stay here, but B would go out. I think I said this. Right? So first in, last out, right? It still stays here. On the next iteration, you would ask something out, you would get A out. So first in, last out, that's stack. Q is first in, first out. Yes. And for breadth first traversal, as we're gonna see, we want Q to use for this. So first we need this queue. So let's create a queue. In JavaScript, it's kind of easy. You do anything you can do. You can do both of these structures on just a regular array, just using a different function calls on them. Let's start with queue. And so first thing you do is you push the root thing. So what push does, it pushes something at the end of the queue, end of the array, right? So this is what we were doing all the time. We were pushing at the end of the array. So that's going to be the same no matter if you're doing with queue or stack. So you're pushing one thing after another. It was empty, so it doesn't really matter, but we pushed at the end, so A is here now. So at this point, well, after this instruction, our queue has A in it. Right? And then we're gonna, so you're gonna do a while loop here. And the condition is gonna be if Q, do we have size here? No, length, yeah. So you're saying if Q is non-empty, keep doing this, whatever we're gonna have here in this loop. Oh, and we also want, what we're gonna do in this loop is take out the items. So let's collect them somewhere, like nodes maybe. So this is the nodes variable that we're gonna collect items into. So here we're gonna say nodes, and then Q. Now there's a pop method, which is like this is a reverse of push. Now what does this means? That it takes from the end. So that's stack thing. That's not what we want here. Because it would take from the end of the queue, not from the right. It would do this. It wouldn't do queue thing where we want to take from the front of the structure, the array here. But JavaScript has another function which is on shift, I think. No, that's to insert elements, to insert at the start of the array. That's not what we want. So it's shift then. Let's do this. Removes the first element from the array and returns it. Exactly. Right? So this thing will do, well, sorry. Let's name this current node. So this will do two things. It will take the current node, the one that we're looking at right now, put it to this variable, and it will remove it from this array structure. So we will do this thing. So in the first pass of this cycle, the current node will have A in it, and the queue will be empty because there's nothing in it else than that. Right? And then let's just do this. Let's just put it to our nodes where we're collecting stuff. And return nodes. Right? So we got this current node, we're just pushing it to this node. Here is the section, here's the action part. Right? Here is where you would do something with the node that you're traversing. So if you do breadth first search, here is where you would compare this node to the thing you're looking for. But if we're just doing traversal and we want to return nodes in an order, we're just going to push them to this collection. And we return nodes here. Well, and then the hope is then the queue is empty on the second pass, so this will exit and return nodes. So if we write, we should just get back array with just the root in it, just one element for now, but just to check that we're on the right track. And this is very powerful thing about tests, because takes me no time at all to run this and see what we're getting back. Cool. So this is a little bit confusing or harder to read maybe if you're not used to it, but it gets better. So it says that the expected has 4 more elements than what we received, and received has no extra element from what we expected. And when you look at this color-coded thing, we can see that A is here, that's why it's gray, but then there are 4 more that are expected that we haven't received. That's why, because we just implemented, the first pass. We haven't looked at the kids, like the children of that node. Hope that makes sense. Anyway, so let's try to implement it further. So I'm going to get rid of this. And then the second part, then we have action. And then the second part is to, well, let's call it explode. Or like children. So we're going to look into what this, what are the children of the current node, right? So we can do is, oh yeah, so we have this graph, if you remember, and we can say current node, and this should be the children. I will explain in a second. So the current node holds letter A in it right now, right? Graph is thing we got from here, and if we look in our test where we defined it, it's this variable, so it will go here, we'll check for A, and we'll return this array which has 2 items in it, B and C. Let's do one more thing. If something doesn't work for you, the easiest thing, well, good thing is to set up a debugger, but that's, doesn't always work, needs some tinkering sometimes. What you can always do, it's just print out stuff, right? So you can just say my test and say children here. So console log is a way you print to standard output, and this is just the text we're putting in out, and it takes how many parameters you want. So I'm just putting my test here, my string, like a string, and then the children we got here, just to verify that I'm getting the correct thing in. So if we run the test as well, it will go through the it will do the same thing. It will show you the standard output as well as running the test. So it runs the test, we saw that's why it's failing, but it also shows us the output here. And we can see that the thing we get is the children, is what we expected. So that's all good, right? And then, yes, then, right, so we have a children, and now what we want to do is kind of stack them at the back of the queue so that they are next to be processed. Boom. So we have a queue. I don't know, how do you push multiple? Push is for one thing, right? I guess there should be concat. Yeah. So we can do this. Concatenation means it will take this array and push it at the end of this array as it is. But the thing is, this is so-called unmutable, so it won't change the queue. It won't change the queue itself. It won't change this thing. Instead, it will return a new queue kind of thing. But this won't work because our check here is queue. Right? We're not looking for this new queue, we're looking at queue. So what we could do, or what we should do, is return it to queue. But now what we're doing is modifying this constant. So that's one of the drawback, I guess, of this approach. Well, I guess you need to do that recursion as well. But maybe not. You might not need to do that. But we can always change it to be like a variable. In this case, it makes sense to actually be. I guess when I was talking about the const, I was trying to get to that you should default to have stuff constants, and then if it turns out that there is a good reason for them to change, then you can change them to be like variable that they can change. Because in this case, we actually want the queue to change and to include the children in here. Yeah, well, you know what, let's keep this log here. And let's put the current node and the children, just to see, you know, what's happening on every pass of this thing. So if we run this again, cool. So the test failed, but it's actually passing. I'm gonna explain it why in a sec. But let's first look at what we got in the console. So it's first looking at the A. How do I show it nicely? Well, let's run it in here, I guess. We have the graph here, so we can talk about it a little bit. Sorry, this is small, but maybe it works better here. So it first looks at A, and it gets two children, B and C, B and C. And then the Q, well, let's put the Q there as well. Sorry, I'm jumping around, just trying to make it. And then Q, All right. So first we have A, and we found the two children, B and C, right? And we push them to Q. So in Q we now have B and C. The next one, no problem. I will upload it to YouTube afterwards, so you can see a recording of it. No problem at all. And yeah, so the Q has now B and C. So now we're gonna pop B out, right? So that's the next step here. The current thing we're looking at is the B node, and it has two children, D and E. And what we're gonna do is push them at the end of the queue. But because we popped B, it's not in the queue anymore, right? Popped B out. So there's just C left, and then the new children, D and E. Well, the next one is C, because we're going breadth first search. So we're going on the level. So we're taking C out. And then looking at its children, and it has no children, so we're putting nothing in there. There are just the children left from the B. And then we take D out. And then that has no children, so we don't add anything more. And then we take E out, and that's it. No children, so that's where it ends. You can get rid of this line. And I can hide this. Cool. And then, yeah, but it's still failing, right? So how come it's failing? Well, if we check the text here, it's failing because it's doing a quality check, not how you call it, well, this identity and equality, I guess. One thing is that it doesn't check that A equals A as a letter equals a letter, but it actually checks that it's the same object, like same memory address, which is not true here because it's a different A than different. It's kind of confusing, but basically it's too strict comparison for us to work here. Because in our test, right, there's one A here, kinda, and there's another A here, and they will both be like a different memory area, so they are not the same, like a memory block, but they are still same values. And for our purposes, we just want to have it as the same value. We don't care if it's like a same object. But in some cases, you would actually care that it's the same object. So, but it's more into like object programming, and it's more difficult maybe to explain. But luckily, Jest is quite clever, and it knows that this is a common problem that you do. So do you really want to do 2B, which is the very strict comparison? Or do you want to strictly equal? Because the strictly equal is less strict than 2B in this case. Because this means it can be two different objects, they just need to be exactly the same. But this means not only they need to be exactly the same, but they need to be the same thing, they need to be the same object. But this is fine for us, two strictly equal. So we're just gonna go here and replace this. And then, yeah, let's do it on the big screen. Cool, so this time it passed, right? This is beautiful. This is what we were looking for. Yeah, so I guess to recap, this is the implementation we've done. It's the iterative approach, so we're not calling function within a function, but we're getting this result. Now, if you would like to, if you would like to do a search instead, instead of this action, you would not collect the nodes, but you would compare maybe, if current node equals whatever I'm looking for, target, then you would do something else, right? Maybe you would count how many steps it took you to get here or something, or just, returned current node, just, checking if it is there or not. Otherwise you would return nothing. But that's not what we're doing, right? We were doing traversal, so our point was to collect all the nodes in the correct order. Well, let's try for fun to do the other approach. So I'm gonna take this method. Well, let's not do that. Let's just take this. So the other approach is the recursion approach, when we call where we call the function from within the function. So we need to rethink this a little bit. So the root will be, in our case, let's name it current node. We still need the graph, but we also need the queue here, which I will explain in a minute. Because, yeah, you need to pass this along. And then I'm thinking how to do this correctly. Well, and then you also need to kind of collect results somewhere. Yes. Or no, do you? I guess you don't. Let's see. Let's try this. So the current node queue is empty. Yeah. Okay. And then let's say recursive, like this. As always, going to this badly prepared. So I'm kind of trying to figure out what I'm doing when I'm doing it. But let's start with this, return nothing. And going back to our test case, the test case will be exactly the same. From the outside perspective, nothing changes. Except we're gonna call the other method. Because that's the abstraction we want. Well, actually, yeah, let's keep it this way. So we're gonna change the implementation of this without changing the interface of it. So we're not gonna change how you call it, what it does. It will do exactly the same thing. We're just gonna change the way you can implement this. If we look at this, we have 3 parameters here, but we're just sending 2 in here. We don't send the queue because that's like an implementation detail. So that the code doesn't need to have a queue, doesn't need to know about the queue. What you can do here is just to init it. So doing this means if it's not provided, this is a default value. If this queue is not provided, default it to empty thing. So that's what we're doing. And then if we run the test, right, 1 failed, 1 passed here. 1 failed, 1 passed. 1 is the one non-recursive one, but the recursive one is failing because we're returning nothing. That's good. So how do we do this? So if the queue is empty, let me think. So we first need to process the current node. Let's do that. Let's call it action again. Yes. So let's say nodes, right? Yes. No, sorry, I'm still thinking about it a little bit, but let's put the current node here. We might need to refactor this later. Just need to get it out a little bit. Then we need to explode as we did before, like get the children. So that's still the same thing. So we get the children, just graph and current node. We still put that at the end of the queue. But this time we don't need to change it actually. So let's do new queue. And we're gonna do queue concat children. That looks good, I think. And then if the new queue is empty, so we said length, then you return the nodes, right? Because you don't have anything else to look at. But if it's not empty, which is most of the time, what you want to do is get a new current node by again taking a queue, new queue, and then shift it out. Right, and then you wanna get the rest of nodes by calling itself, sending the same graph in, but the new current node is this new node, and then queue is the new queue. Hope that makes sense. But it's pretty hard to think about. Now I'm trying to think about. And that's the rest of the nodes. And what you want to do is the return nodes, which is your current nodes, with rest of nodes. I think that should be it. Let's test it. I might be totally wrong. Okay, well, I'm wrong for some reason. So we only get A back. Let's see. We get 8 because nodes, and then new queue. So let's do the thing we actually did before, but this time I actually need it, and print out what's happening here. So let's say current node is whatever current node, and then new queue is new queue. Right, let's do that. Okay, so it said current node is A, new queue is this. But it's somehow still returned, which is confusing. Let's see. Oh, I know. Do you know where the problem is? Yes, so here I'm not actually calling itself, as you can see. I'm calling the previous implementation. So this should be recursive. Let's see if this fixes the problem. It did not, but it's yeah, that was a problem as well. New queue is B and C. Alright, let's see what happens next. So that's just before we do this check, right? So let's write some more logging here, saying something along the lines queue is empty. And here queue is not empty. And one thing we want to test here is the rest of nodes as well. So let's see how that works. Well, now I'm just clueless what's broken. So this is what you would do. You would just add some logging, try to figure out where the code doesn't do what you expect it to do. So now it's saying current node A, new queue is BC. I expect the new queue should hold this now, but still it goes to queue is empty for some reason. Yeah, okay, so now I see. Because my check here is actually incorrect. It's supposed to be not length. So if the new queue is empty, or let's write this, is queue empty, and you do new queue length. So what I've done here is, because it confused me, it might confuse somebody else reading the code after me as well. So I moved it out, called it what it is queue empty is the name of my Boolean variable, and this is not operator and not length, and then numbers in JavaScript, if they're evaluated, sorry I didn't mention that before, but if they're evaluated in true-false scenario, then it's like 0 is false and any number is true. So that's why. Why empty queue didn't have A? I was wondering why empty queue didn't have A. Which queue did you meant? There are plenty of queues here now. Well, one thing we're doing at the right when we're going the first time, the queue is empty, but then we add children to it, and what we look at is the A and take the children of it. We never add A to it. We only add children of A to it. So let's actually try to run this now, and yeah. So let's try to run this now and see what we get in the log. So we got passed, which is great. So it probably works now. Let's review the logs now. So we're going there for the first time, looking at A. New queue is children of queue of A, which is BC. Then we're looking at B, and the new queue is CDE, because that's right. C is left from here, and then it explodes B and looks at its children DE and puts them at the end, and then it continues further and further. When it finds nothing, queue is empty, right? So in this case it's doing E. Let me put one more log to make it even clean, maybe more easier to understand. Let's add the current nodes, because that's kind of tricky part here. Here we go. Can you see it? I don't know. Queue is empty here, nodes. So here it says queue is empty and I'm return nodes, and it only has E in it, because that's the level you're on, right? You're on the least child. It's when you're starting to get back in these recursive calls. That's why it's kind of difficult to think about, because you kind of think one way and then at some point it starts breaking and the escape condition starts to kick in and you're starting to get back to your caller, to the caller of the caller, and it's a bit harder to think about. So right here, first time we hit this is actually when the current node is E, right? So nodes is only E in it, nothing else, just E. And then the E doesn't have any kids, so Q is empty, and then it returns array with E only. But then in the previous call to this thing, when we check this for E, we would get here the array with only E in it, and then put it at the end of whatever this thing right now has. So it's kind of tricky. Yeah, works in the end, but yeah, that's the thing. Cool. So this kind of works, I think. So what I'm gonna do next is I'm gonna take this code, clean it up a little bit, remove the implementation part of it, and upload it to GitHub, I think, create a repo there, and I will ask you to kind of fill in the blanks, make sure the test passes and everything works, and then create a PR there, pull request, so that, you know, we can talk more about the code. If you have further questions, we can do that. And the first person that submits the PR, I will merge it, so your name will be on the solution, so it will be really good. Plus you get some sweet, graph points in the GitHub, which looks really nice. Yeah, I will also archive, as I mentioned, this to YouTube and put more description how to do that and links to the GitHub there. Yeah, unless there are further questions, are there any? If there are none, then I'll do that. And please do let me know if you would like me to go through some other code or some other scenario, so we can do that. Right, bye. Need to figure out how to turn this off.